Hello everyone, happy Thursday. Today we're going to start section 12.1. This is our last chapter for the year and we're just again dipping our toes into it. So chapter 12 is going to be talking about limits, which we actually talked about at the beginning of the year. So let's refresh your memory. So if you recall, a limit is the value that a function approaches as the input approaches some value. So basically today's stuff is recalling exactly what we did at the beginning of the year. Full circle. So limits and end behavior. So if I am saying, I'm going to give you, I want us to find the limit of f of x, and I'm going to say f of x equals x squared. I want us to find the limit as x approaches positive and negative infinity of f of x. So that's what we're doing. We're asking, okay, from the right and the left, so remember the plus and the minus, what is happening to our function? What is it approaching? So, if you remember, we need to make a table. And remember, this is saying as x approaches plus and minus infinity. Now, if we're talking about our x values, let's think of a graph. That's going, x values are getting bigger and bigger and bigger, and smaller and smaller and smaller, right? Positive infinity and negative infinity. So the first thing we do is we make a table. This is required, remember? And in our table, we know the x values because we are choosing them. Because it's going to negative infinity, and we're getting bigger and bigger and bigger, we're going to choose bigger and bigger and, well, I guess smaller and smaller numbers. So we do negative 1,000, negative 100, negative 10, and then we have 0, and then we get bigger, so 10, 100, 1,000. So the x values are kind of based, well, not kind of, they are based on this. So we're approaching positive infinity with our x values, and we're approaching negative infinity with our x values. Now what we do is we substitute in our values. So substitute this into f of x. So here, instead of having y, let's change that to be f of x. So when I substitute in 0, we get 0. Using a calculator, when I substitute in negative 10, we get 100. Well, you don't need a calculator for this, hopefully. When I substitute in negative 100, negative 100 squared. Is that enough zeros? 10,000? Yeah. Okay, negative 1,000 squared. My zeros. How many do I need again? 6. Yeah. Okay. Then we do our same thing. So 10 squared, 100 squared, 1000 squared. Now we look and we go, okay, well, what is this telling us? This is telling us as x values are going towards positive infinity and negative infinity, our y values, f of x, is approaching, well, these are just getting huge, so positive infinity and negative infinity. And now we just need to make our conclusion statement. So our conclusion statement is the limit as x approaches positive and negative infinity. And please remember that this x approaches part is underneath just the limit. And then f of x is lined up with the limit part. And it is going to, I don't know why I said negative, these are all positive. Positive infinity, because from the right and the left, it's going to the same direction. Okay, so then another example is if it's approaching a number. So let's do, let's write it as the limit as x approaches -3 of 1 minus 5x. So I'm just writing a little bit different. Last time I said f of x and then put f of x here. That means that this is our f of x function. So first step, make a table. Now for 3, we're asking if it approaches -3, so that's what goes in the middle of the table. And then I want to make sure I give myself enough space. And this is where, so we want 3 to the left, 1, 2, 3. Then we have -3, and we want 3 to the right, 1, 2, 3. Okay. So a little bit to the left, because it's approaching -3, this is where we're like, okay, we want something really close. So we're going to do -3.001, -3.01, and -3.1. And then to the right, really close is -2.999, -2.99, and -2.9. And now we do the same thing and we substitute it into our f of x, which this time is 1 minus 5x, so just be careful. To recap, as x is approaching, so x is from the left getting really close to -3, and then from the right also getting really close to -3, which is what we want. Now we want to ask ourselves, so what is happening to the y values? So first of all, when we substitute in -3, what's f of -3? Well, that is 1 minus 5 times -3, which is going to be positive 16. And now we want to see from the left and the right, is that also happening? So is it continuous or is there a discontinuity? And remember your discontinuities, which is not a big deal for today's stuff, but just to recap, remember there's jump, infinite, and removable. So we're going to substitute in -2.999, and in our calculator we get 15.995. And then -2.99, we get 15.95 when I substitute it into my calculator, and 15.5. Remember, decimals are okay. In fact, you need to have decimals. You shouldn't be rounding to the nearest whole number unless there's just like a crazy ton of zeros coming after it. So like if this was 16.0000000005, yeah, I'm not going to make you write all that. But for the others, we should. Now we need to, now that we figured out our y values, make a conclusion about them. And from the left, it looks like we're getting really close to 16. And from the right, it also looks like we're getting really close to 16. So that means the limit as x approaches -3 of this function, we're approaching 16. So let's just do one you try, since you guys are probably, or hopefully, familiar with this. All right, let's do the limit as x approaches -1 of x squared minus 4x minus 5 over x plus 1. And I am going to request that you pause the video, try to do this on your own. Alright, so I didn't finish the entire problem, but I did start the table. So because we're approaching -1, I want to get really, really, really close from the left and from the right. So that's why I chose -0.001, -0.01, -1.1, and then -0.9999. Now we're going to substitute all of these into the equation. So when I substitute in -1, it's undefined. Okay, but remember, that just means f of -1. The function has a hole here, or an asymptote or something, but that doesn't mean the limit doesn't exist, so we still have to complete the table. It just means there's discontinuity. So when we substitute in -1.1, we get -6.1. And again, I'm just using my calculator for this. And then I'm getting -5.999, -5.99, and -5.9. So if I'm looking from the left, I'm like, okay, well, this is getting closer and closer and closer to -6. And this also from the right looks like it's getting close to -6. So remember, that's a removable discontinuity, but because they're approaching the same number, there is a limit. So the limit, as x is approaching -1 of this function f of x, we are approaching -6. And that's it. So you need to show your table, you need to label your table with the arrows, and you must write a statement. All of this is required work. So hopefully that makes sense. Remember, you can come to flex time. Hopefully your homework makes sense. Contact me if you have any questions.